Okay, hey everyone. So this is the walkthrough for Lab 1. Um, Typically, I would like to have a PowerPoint or something that kind of corresponds to the video, um, but I was having problems embedding the video into the PowerPoint without it um, reaching the maximum 2 gig limit for Cougar View. So I'll figure that out hopefully before I load up Lab 2. But I wanted to go ahead and get this out there because Lab 1 is actually fairly easy. Uh, Usually, I'll just get students to look up a lot of this information online, double check your sources, of course, make sure that you get the right answers. But you can fill out a lot of the Chem 21 lab report without any assistance, right? You just kind of look it up, and we'll go over it step by step. I just want to show you everything that is available to you so that you'll know where to look when you have questions. All right, so first off, we are in Cougar View. When you come into Cougar View, it'll open up the lab section of the course. It'll bring you to this home page with the announcements. Go to content, and you'll see all the labs here on the left-hand side. Okay, so whichever lab you're working on, you want to have this pulled up and, and have the information that corresponds to the lab report. So this is where you'll actually get the information that you use to fill out your lab reports. Okay, and it might be a PowerPoint, it might be this video, walkthrough video, um, but the information that you need to fill out your lab reports in most cases is going to be here in Cougar View. All right, so you have a pre-lab discussion, as I said, from Dr. Taylor. Uh, so she has PowerPoints as well, along with her videos, and it's nice and smooth, but she covers all of the information that you need to complete this lab. Okay. So if you have any questions about anything in the lab and you haven't watched the pre-lab discussion, go back through there, watch that, and more than likely we'll discuss whatever questions you have. And you can obviously email me if you have any questions as well. The lab guide is also a good place to look, um, just to kind of get information on what it is you're supposed to be learning. So, for example, it talks about what physical properties are, what solubility is, what combustion is. So, if you have questions about any of these problems on the lab report, refer back to your lab guide and it'll probably go through at least a portion of it, right? And yeah, a lot of useful information here. This is actually a great kind of study guide when you get ready to do uh, the midterm. All right, go back over these lab guides because they have all the information that we're really hunting. There's somewhere in these lab guides. All right. So yeah, I ain't going to talk about each portion of this, but I am going to walk through uh, the actual Chem 21 part. Okay, so Chem 21 is the program that you should already be registered to. When you open it up, it might look something like this, might look a little different, but we're going to work Lab 1. Okay, now you'll notice a little tab on the right hand side that says Next Problem. So it's not responding. Give it a second. Okay, there we go. Okay. Little tab on the right hand side that says Next Problem, Submit, Skip and Work Later. Uh, when you get a problem wrong, it'll show you what portion of the problem you got wrong. So this is, for example, the chemical symbol, the symbols or the formula for sodium chloride, which is NaCl. Okay, and it told me that I was wrong. I typed in NaC, and it said that the NaC was right, but the red box indicates that there's something wrong after that. So I left off the L for chlorine, right? And try two, I got it. Okay. So it'll give you feedback on its own. It'll automatically grade portions of the lab report. skip and work later. So these are just essentially tables that we want you to fill out. Sodium chloride, its physical state, right? Solid, liquid, gas. The melting point, which you can look up, but Jamie might have in the videos. I'll go to the video here in just a second. So you go through and fill out these based on uh, your knowledge of the compound. So sodium chloride is an ionic bond, for example, ionic versus covalent, right? You should have learned this at some point, and Dr. Taylor also talks about it. The lab guide talks about it. So I ain't going to waste too much time going over, but all of this information um, you should be able to find out one way or another. Okay, you saw there. I've been going through and just making sure that everything matches up with what we have on the videos. So let's go to the video. I want to play that for you, and we'll stop when she gets to the first portion so we can go fill it out in our lab report. Okay? So Jamie Gonzalez, the lab coordinator, did these for us. And typically they would be in this PowerPoint form. Um, we're having some technical difficulties here lately, though. So hopefully I can get all this together and have it nice and neat for you on the next lab. Part A, comparison of organic and inorganic compounds, physical properties, display of compounds in vials, sodium chloride, potassium iodide, toluene, cyclohexane. So she does go over that first portion that we were just working on filling out. But these are known melting points, known physical states. In a lot of instances, I could probably do this from memory, right? The molecular formula is something that you should be able to deduce in some cases, like sodium chloride, for example. But uh, some of these organic compounds you're not going to be familiar with, and I'm not even familiar with to a large extent, so you have to look them up. And that's all we do here. We look up the compounds in lab on safety data sheets, and we're required to keep those to know how to treat chemical burns or toxic, if anything's toxic or whatever, or if something's flammable. So it's important for us to have this information handy when you're in the lab. All right, so here's part A1. This is what we were just looking at, the table from Chem 21, and it tells you we want to identify the molecular formula, physical state, melting point, types of bonds, and whether or not it is organic or inorganic, and whether or not it's organic or inorganic depends on the type of bonds, right? If you have um, ionic bonds, then it's typically going to be inorganic. If you have a bunch of carbons and they are covalent bonds, it would typically be organic. That's just a kind of simplified rule, but it's one that will work in a lot of cases. All right, so here's sodium chloride. Uh, chemical formula, NaCl. Melting point is 801 degrees Celsius. Okay, so very high melting point. Use this information to fill out your uh, lab report. Next up, we have potassium iodide. There is the chemical formula, Ki. There it is again. And the melting point looks like 681 degrees Celsius. So also a very high melting point. All right. Next up is toluene. Notice this in a liquid form. So that's a physical property, correct? Toluene chemical formula is C7H8. And the melting point is negative 93 degrees Celsius. Now, before I continue, I want to show you something else in Chem 21. So when you are doing, let's go to this one, uh, C7H8. So when you enter in, what do you call them, subscripts for the carbon and hydrogen atom, right? That's these little numbers below the C7H8. If I put in cyclohexane, which is, I forget, C6H12, I can't remember. Oh, and I can't see it. I'll back it up. Yeah, C6H12. So let me do this one real quick and show you how to work this keyboard. All right, so you have to roll up. I'm on Chem 21. I'm back on Chem 21. I'm getting ready to enter my answer, but I have to have a subscript for the number of carbon atoms. Roll up here to the top and you'll see Show Hide Keyboard. Okay, click on that. Now, when you click on this little text box here, I can type in capital C, right? Carbon is a uppercase C. And then if I want a subscript, I go to the bottom row of X's here. So in this case, I want 7. You might not can see it on this video, but it's X0, X1, X2, X3, so on and so forth. I want the 7 subscript. Wait, we're doing cyclohexane now. So I want the 6. Oop, and that's why you can't just type 6. You have to do this little X here. All right. And if I wanted a superscript, I could do this one here and it would put it above for like a charge or something. So just keep that in mind. H, and we want 12. So X1 and X2. Okay. Now this is important. I can't get it to work when I click on copy to clipboard. Okay. I also can't get it to work when I highlight it and I do Control C. The only thing that tends to work every time is to right click it, copy it, hide the keyboard, come down here, right click it, and paste. Okay? So that's how you have to enter in the subscripts on Chem 21. And as you see here, I tried to just type C7H8 and it wouldn't accept it because it needs to recognize those subscripts. I just wanted to see if it would take it, and it didn't. It gave me an incorrect answer. All right, so next up, oh yeah, I gotta show you what the properties for cyclohexane were. Let me go back a little bit. Pop, pop, back it up some. A little more. I'll just start back at toluene. So that's the toluene C7H8 formula. Melting point negative 93 degrees Celsius. So a very low melting point. You'll notice a trend in this, whether or not it has a high or low melting point. Cyclohexane C6H12. C6H12 is the chemical formula. And the melting point also should be really low, 4 to 7 degrees Celsius. Calculate the average between 4 and 7 degrees Celsius. All right, so solubility. Solubility is when something dissolves into solution. And so we're going to look at samples containing sodium chloride, table salt, or toluene when you add it to cyclohexane and water, or vice versa. I'll give you a second. I can go over this. Observe the sample in which the sodium chloride is added to cyclohexane, a nonpolar solvent. Record whether sodium chloride is soluble or insoluble in cyclohexane. For number 2, observe the sample when it's added to water, a polar solvent, and note the differences, right? Identify sodium chloride as organic or inorganic based on these results, right? If something's organic, we would expect it like dissolves like from your pre-lab discussion in your lab guide. We would expect that organic molecules will dissolve in organic solvents. and inorganic molecules will dissolve in polar solvents, right? The ions, the difference in charge makes them easily soluble in a polar solvent like water. Okay. Next up, observe the sample which toluene is added to cyclohexane, a nonpolar solvent, and observe the sample when toluene is added to water, a polar solvent. Again, identify toluene as organic or inorganic. All right, so that's sodium chloride in cyclohexane. Notice that all the salt is still there at the bottom. Okay, shake it up, no matter what, it's going to fall back down to the bottom. All right, here is sodium chloride in water. Same amount of sodium chloride, I might add too. In water, it's completely gone or dissolved. All right, so toluene in cyclohexane all looks like the same thing. There's no delineation. Remember, toluene is a liquid, so you got a clear liquid on a clear liquid. But notice here, the two liquids separate. One is polar, one is nonpolar, so they do not mix. They are unalike and therefore not soluble. Okay, so combustion, part A part A dot 3. Combustion is when something burns in the presence of oxygen, and typically you're looking for something with carbon atoms, because what happens is in a combustion reaction, carbon hydrogen bonds are broken and carbon dioxide is formed and let off as a gas. Okay, but combustion means it's also in the presence of oxygen. You have to have oxygen there for the organic molecule to undergo combustion. All right, so record whether or not sodium chloride undergoes combustion, and then record whether cyclohexane undergoes combustion. And let me stop there just to go back to Chem 21 and make sure that you're following along uh, where you should be. So we got to solubility, right? We filled out this table using that part of the video. Now we're on combustion. You're going to fill out this portion based on what we're watching now. Oh, I went too far. Sodium chloride. And in a combustion reaction, you'll see some type of uh, evaporation of gas, or the molecule will go away, some indication that combustion has occurred. So this is cyclohexane. And there you go, that's combustion. It generates its own energy, so it can keep burning until you're out of carbon atoms to combust. Okay. So now we're on to part B, which is the structure and names of alkanes. So for those of you in the lecture portion, you want to have already completed this part of the lecture so that you're familiar with everything that's going on here. All right, so these are three-dimensional models. Like I said, typically I would just have you look all these up and find them on your own. All right, and we're going to have you draw expanded and condensed structural formulas, but I'm not as concerned with you actually drawing them, and I'll show you what you can do instead. Let me let her get through these molecules. Okay, so let me pause it there. Go back to Chem 21. I want to show you all this. Um, I'll explain this one real quick. So based on what we did with sodium chloride and cyclohexane, you should be able to tell me about patterns or trends that each had when it came to their bonding, their melting point, their solubility in water, um, what type of elements are found in organic versus inorganic. Remember that organic molecules are a lot of carbon hydrogen atoms that are covalently bonded so they can combust, right? The carbon is necessary for combustion reactions. They typically have low melting points. All of this information that we've just concluded from looking at sodium chloride and cyclohexane. All right, a couple of questions just for you that can be written out. Now here's where she's at now. She just showed you molecules of methane, ethane, and propane. For these, they want you to upload an image. Now I don't mind if you write out the expanded structural formula, take a picture with your phone, email it to yourself or upload it here somehow and do it that way. Another thing you can do is just look it up, Google it, and make sure that you get exactly what you need for these questions. So the expanded structural formula, I was looking at toluene earlier, which is a more complicated molecule. So this is the model that, like something that she was showing for toluene, but an expanded structural formula will look like this, right? With every carbon and every hydrogen listed. So this would be the image that I would use for expanded structural formula. Now for the other one, what's the other one? And the formula, the regular formula. So that would just be um, C7H8. Okay. So you can do that however you want to do it. You just upload the images there, and then when I scroll through, excuse me, you upload the images there, and when I scroll through, I can just see your picture and automatically tell, okay, that's methane, that's an expanded structural formula, that is condensed structural formula, or whatever it needs to be. So here is expanded versus condensed. Let's see if Jamie does anything in the video for that. Okay, so this is a standard butane. We're actually at the isomers part. Oh yeah, this is expanded and condensed structural formulas. Okay, so this would be just a model, doesn't necessarily represent the expanded, and it really doesn't represent the condensed either. This is just a model to help you see what is going on. Okay, let me back up and kind of go over that part there. Pause. Okay. So you'll have to look up the molar mass boiling point density of these isomers on the internet. Uh, and she wants you to draw condensed structural formulas. I don't mind if you don't draw them, same thing. Uh, a condensed structural formula is something like this, where it just has the lines and not necessarily the entire uh, list of atoms, right? Like we just looked at, this was an expanded structural formula. What you're talking about for butane, let's say, let me do the butane right here so you can see it. So all of this will be expanded. The C's and the H's up top will be an expanded structural formula, and the condensed structural formula would just be the lines. So where is that at? Nope, nope, nope. C4. My internet's adding up. I think a storm's coming in. So in some of these cases, you might have to draw it if you can't find butane condensed structural formula. Yeah, I don't mind if you do it like that. Condensed formula. Yeah. I mean, I would also accept the line drawing. Okay. So that's just how you do that portion. Let me look on Chem 21 and make sure that gets us past that. So you upload an image here. The rest of it is the internet. Um, and really the same for the next section, right? Pentane, methylbutane, dimethylpropane. So three different isomers that you can find images for, condensed structural formulas, and expanded. Edit answer. Okay. I think it'll let you add both images there. Not real sure. But if it doesn't, go with the condensed. All right. Let me just make sure, see what Jamie's going to do. All right. So these are cyclic alkanes. Uh, Organic carbon molecules, hydrocarbons with ring in them, cyclohexane. The pentane, pent meaning 5, hex meaning 6. So you'll learn all of these prefixes and it'll kind of give you an indication of what it is. So when I hear hexane, I automatically know 6 carbons. Haloalkanes are alkanes that contain a chloride, bromide, iodide, uh, mm, yeah, bromine, chlorine, fluorine. Fluorine is the other one. Iodide. So she only goes over the 3. I think fluoride is usually highly reactive, so we probably don't want to mess with that as much in general. Okay, so let me stop there because I wanted to show you there's one more new kind of addition to the labs that you're going to have to get familiar with, and that is drawing compounds. For those of you in Alex, you're going to have to learn the Alex program how to draw compounds, and in the lab, you'll have a different way of drawing compounds. So you have carbon atom, you have your atoms over here. You can click on whichever atom that you want to use. I'm going to start with a carbon, and we'll put it there. If I want another one, I can put it here. If I want it to erase, I can only erase one atom at a time. Bop. So let's go back here and make a bond somewhere, right? You can do that a couple times. It automatically fixes it so that it's in the right proportion. The line angles are correct. So you add carbon atoms like that. I can also do a ring. So say for example, I have to do a cyclohexane. I have to change it every time, though, don't I? Cyclohexane, or excuse me, chlorohexane. I can click on the chlorine atom and I can put it right here. Right. Like that. Okay. So I drag it out from wherever I want it bonded. So that's actually a pentane. If I wanted a hexane, I go over that little arrow and I can put out a hexane. This is what, a heptane with 7 carbons. So play with that a little bit. You're going to draw your own molecules in Chem 21 as well. This is dichlorocyclohexane. So I was, no, I wasn't there, but I would add a chlorine there and a chlorine there, and that would be a dichlorocyclohexane. Make sure you clear off ones that you ain't using. So I did a lot of wastefulness there, but you have to go back and click on the eraser every time. So it's kind of a pain, but you'll get used to it and you'll make less mistakes and it'll get easier as you go. All right. So let me go back to the video and let's finish up this here. Functional groups. So in the lecture, you'll learn about different functional groups. This is an alcohol because it has an OH on the end. Well, I guess I just gave you the answer. I ain't gonna say no more. But you need to learn what each one of these molecules are a specific type of functional group, and you will list that on your lab report. Okay? And like I say, you can just go through the video, pause it, um, go back and forth to the internet, figure out which one's which. But all of these are the different types of functional groups that you need to recognize going forward, right? I'm pretty sure Chem 21 lists them. Hold on, let me make sure. Let me let her finish. Okay, let's go back to Chem 21. What part am I on? Functional groups. Yeah, they okay. So she has pictures of them in Chem 21 as well. So you don't have to necessarily go back and forth to the video, but go through and tell me what type of functional group each one of these are. Classify each of these according to their functional group. So we're trying to throw a little wrench at you, make them a little bit bigger. You still have to go through and see the most important functional group, right? Uh, I usually start with the oxygens. Oxygen signals to me there's something functional there because oxygen is very reactive, and oxygen and nitrogen, right? If you don't see oxygen and nitrogen, then the chances are it's just a simple alkane or alkene or alkyne. Okay? Alkynes are triple bonds, which I don't know that we get to just yet. So, all right, that should be it for Lab 1. This is just kind of tedious, a lot of internet work, a lot of figuring out how to use the program, but it shouldn't be that bad. If you have any questions, you can email me. I'll get back in touch with you as soon as possible. Okay, that's it for this one. See you next time.